Hey students, this is lesson 2A. We're going to find how to find missing links in similar figures and to use similar figures when measuring indirectly. Go ahead and do this review and I'll check back with you. All right, just a little note here. This little symbol means similar to, and the ideas about similar figures that you need to remember is that the measures of the corresponding angles are equal and corresponding side lengths are proportional. So if we look at this first figure here, and we know they're similar by what this says. It says triangle ABC is similar to triangle DEF. What we're going to use is the idea that the ratio of corresponding sides are equal. So if I look at, like, say, the ratio of, let's see, we want to know what is DE, so I'm going to mark DE right here with an X. And so I'm going to write X over 10, so the ratio of two sides from this triangle. That has to equal the ratio of the same two sides, the corresponding sides they're called, on the triangle that's similar to that. So that would be the 4 and the 5. And the X corresponds to the side with the 4, and the 10 corresponds to the side with the 5. So I'm going to write 4 over 5 there. Then I'm just going to use the cross products property, and 5 times X is equal to 40. Divide both sides by 5, and I get X is equal to 8. All right, you try that. All right, problem 2, applying similarity. It says the student who is 5.25 feet tall is standing next to a tree. The shadow of the student is 20 feet. The shadow of the tree is 80 feet. What is the height of the tree? Well, since the sun is directing its rays down on Earth at the same angle with respect to both the student and the tree, we can create two similar triangles here. So I'm going to just redraw this real quick. So here's a student, and let's say this line represents the student's shadow. At the same time, there's some tree, and that tree has a shadow, which of course is longer. It says the student is 5.25 feet tall, so I'll just put that in there. And then we get a triangle that looks like this, and that's a right triangle there. Right triangle here, and what we want to know is the height of the tree. So I'm just going to call that H for height for now. And the tree's shadow is 80. The person's shadow is 20 feet. And now we have two similar triangles. Remember, the sun's rays are the same, so those angles are the same. And if two angles of a triangle are the same, then the third angle will also be the same. So that one's going to be the same as that. So I can just create a proportion out of my ratios of corresponding sides. So 5.25 over 20 from the smaller triangle person is going to be the same as the height of the tree to 80 in the other one. Using cross products, we get 20 times H is equal to 5.25 times 80, and 5.25 times 80 is 420. Divide both sides by 20, and I get H is equal to 21. So the height of the tree is 21. All right, and that's called an indirect measurement because we measure the height of the tree without directly measuring up the tree trunk how high it is. All right, I'm going to let you try that. All right, a scale drawing is a drawing that is similar to an actual object or place. Floor plans, blueprints, maps are all examples of scale drawings. So And since they are similar, we can use the idea of similar objects. So of course, the ratios of corresponding sides are the same, or the ratio of corresponding parts are the same. So we're told here that 1 inch represents 12 miles on the map. Let's just write that as a ratio. 1 inch per 12 miles. All right, and we want to know the distance between two buildings is 4 inches on the map. So in other words, like maybe from, I don't know, maybe from A to H here is 4 inches when we measure it. And all we have to do is make sure we line that up in the same spot of the ratio. And then the value that we're looking for, we'll just call that x, which is the actual distance, x. All right, and then we'll just use cross products. 1 times x is equal to 12 times 4. And 1 times x is just x. 12 times 4 is 48. So, and then we'll just label it 48 miles, since in real life we're talking about miles there. All right, you try that. Okay, the scale model is a three-dimensional model that is similar to a three-dimensional object. The ratio of linear measurements of the model to the corresponding linear measurements of the actual object is always the same. So if we measure anything on this model, it will be a certain number of times bigger on the actual. And so we can use the scale. It says that 1 inch represents 8.5 feet. So it's 1 inch per 8.5 feet. And if we're looking for, it says the model is 5 inches tall. So this, I measure this is 5 inches. In real life, there's some corresponding height to that. And we'll just put an x for that. And then again, we'll use cross products. 1 times x is equal to 5 times 8.5. And 5 times 8.5 is equal to 42.5. And so the actual height of the building is 42.5 feet tall. All right, you try that. Okay, we're up to the lesson check here. Go ahead and finish this up, and next time we meet in class, we'll talk about it.